Students, now yesterday we have completed with the new property, that is the property of three parallel lines and transversal. You must have seen over there the yesterday videos, is the property of three parallel lines and the transversal. Okay, on that basis we are going to do the sums, how we did for the BPT ka related sum, then angle bisector ka related sum. Now three parallel lines ka related sums are there. Now here if you see this practice set 1.2 ka question number 5th. Now in the question number 5th, what is given in the trapezium ABCD? You have a trapezium ABCD. You have AB parallel to side PQ parallel to side DC. These three lines are parallel. Can you see these three lines are parallel? And this is acting as a AD is acting as a transversal. Can you see that today? And BC is also acting as a transversal. Yeah, and they have given the value of AB is equals to AP is equals to 15, PD is equals to 12, QC is equal to 14, and they told to find the value of BQ. They told to find the value of BQ. Now, if you see this carefully, that it is very simple and very easy, very simple thing. So you have to how to start it, nothing but you just have to write first in trapezium. You have a trapezium, yes. Now what is the name of the trapezium? Is A, B, C, D, and they have given that over here side AB parallel to side PQ parallel to side DC. Okay, on transversal, we have here transversal, name is what? AD and BC. We have a transversal AD and BC. Therefore, you will be having therefore by the property, we have here therefore by the property of which property we are going to apply? By the property of three parallel lines, three parallel lines. Property of three parallel lines and they are transversal. Property of three parallel lines and the transversal. And what is that property says that? It's very simple. We have what over there here in this case. You know that AP upon PD. AP can I have here AP upon PD. You will be getting what? AP upon PD is equals to BQ upon QC. BQ upon QC. Now BQ upon QC. That's the ratio. AP upon PD is equal to BQ upon QC. Now what is the value of AP? Is here 15. You can see that AP ka value is 15. PD ka value is what? 12 is equals to, you have BQ ka value they told to find out, and then QC ka value is what? 14. Now what to do is nothing but cross multiply. Therefore 12 into BQ is equals to 15 into 14. 15 into 14. Now here you will be getting what? Therefore BQ is equals to 12 is multiplying, it will come and divide 15 into 14 upon 12. 15 into 14 upon 12. So now what will happen today is this will go in 3 ka table. 3 5s are 15, 3 4s are 12. Yes. And then this will be what was it? 2 2s are 4, 2 7s are 14. So you will be getting the the answer is BQ is equals to, you will be getting 7 by the 35 upon 2. Now 35 upon 2, if I try to divide 35 divided by 2, 2 1s are 2. You will be getting what? 15. 2 7s are 14 and my 1, and they have to put a decimal, and 2 5s are 10. So you will be getting the answer. What you will be getting the answer? Therefore, the BQ ka value you will be getting 17.5. BQ ka value you will be getting what? 17.5. And this is how your answer of BQ is 17.5. And it is very simple sum. Okay, students. Now let's go for the next question. That is your question number 7 from practice set 1.2. It is also related to your three parallel lines. Okay. Now here if you check this out over there, they have given that AB parallel to CD parallel to FE. AB parallel to CD parallel to FE. Can you see that over there? And they told to find the value of X. This is they have given BD is what? 8, DF 4, AC 12 and CX. So first they told to find the X. And after finding the x, they told to find AE. They told to find AE. Can you see after finding x? There are two things they told to find first. That is your first is your x value, and then you have to find the value of AE. So first thing we are going to find the x, and then we can able to go to find out AE. Now how to go to this is very simple. Same way you have what over here. In this case AB. You have over here is AB has been given parallel, so I have to write it over here. AB parallel to CD parallel to FE. On transversal. Can you see this transversal? So what is your transversal over here? If we see transfer. Now here if we check this out, the transversal. Now transversal there is two transversal again, that BF. You have your transversal BF and transversal AE. BF and transversal AE. This BA, DC and FE are parallel, and this is acting as a transversal. So when they are having a transversal, so therefore I can apply by the property of three parallel lines. By the property of three parallel lines of three parallel lines, and they are transversal, and they are transversal. So according to this, how should I do? So I will be applying that ratio. BD upon DF is equal to AC upon CE. Can start with it. Your BD upon DF is equals to AC upon CE. So by the property of three parallel lines and the transversal, BD upon DF is equal to AC upon CE. BD ka value we have what? 8, and you have DF ka value is 4 is equals to, what is AC ka value? Check that, 12. What is CE ka value? X. Now what is to be done? It's very simple. Again cross multiply. 8 will go and multiply with X, and 12 will go and multiply with 4. 12 will go and multiply with 4. Now X is multiplying with 8, so 8 will come on the right hand side, 8 will go and divide. So therefore you will be getting what? X is equals to 12 into 4 upon 8. 4 ones are 4, 4 twos are 8, 2 ones are 2, 2 6 are 12, and therefore you are getting what? X ka value, what you got it over here is 6. You got a value of X 6. That is your first question got over. That is what they have asked. X is find the value of X. Now they told to find what? One more question, that is your AE. Now what is AE? Now AE is a line where you have made up of the coordinate points are there. Can you see that over there? Here I can write AE is equal to, can I write over here AC plus CE, and in the bracket A dash C dash E. AC plus CE. Now what is the value of AE will be in this case? Can I write it over here? Therefore AC ka value is what? 12 plus C is what? X. So X ka value we already got it over there. That is your 6. So AE ka value will be over here in this case is 18. So you got the value of AE also. It's very, very simple. We got the value of X and we got the value of AE. Okay, and that is how the sum is over. Okay students, now we are going to go for the question number 4th of practice set 1.2. It's not, we'll come back to it's related to like your basic proportionality theorem. I think that's what we have done last time. In that, this is related to that. It's very simple sum. Here in this, the measures of some angles of the figure are given. Prove that AP upon PB. Can you see that AP upon PB and AQ upon QC? There the angle is being given. APQ they have given 60 degree, and PBC is also 60 degree, and they told to find the ratio of AP upon PB. AP upon PB is equal to AQ upon QC. Can you see this over there? This is what the related to that theorem we have done it over there. So first of all, it's very simple how to write it over here. I'll be writing what? In triangle ABC. In triangle ABC. Can I write it over there? That angle APQ is equal to angle what is that over there? Your PBC, and you have to write over there the reason That is what they are, each 60 degree. Each 60 degree. Now it is each 60 degree. Now here, if these two angles are congruent, so can I say that segment AQ is parallel to side BC? Why? I'll just tell you that today. This is because of corresponding angle test. Corresponding angle test. How it is that the corresponding angle test is there? If you check this out carefully, that here I have two lines coming up, the two parallel lines, and there is a transversal over here. So you can see this P, angle P is 60 degree and angle B is also 60 degree. So you can see this over this angles are acting like a corresponding angles, and the corresponding angles are congruent, then the lines are parallel. If the lines are parallel, now you know that over there, that if these lines are parallel, so can I apply by basic proportional theorem? You know that over there, in a triangle, if a line parallel to the one side of a triangle and intersect the other two sides, then they intersect in the equal ratio. Can you see that over there? So can I apply, therefore by basic, can I write it over here in this case directly? Therefore AP upon PB. If it is parallel, then I can apply that AP upon PB is equals to AQ upon QC, and that's because of by basic proportionality theorem. By basic proportionality theorem. Yes, can you see this today? We got this ratio equal, and it's so simple. I just told that okay, the angles are congruent because of each line TT is 60 degree. If the angles are congruent, then the line PQ and BC are parallel because of corresponding angle test. And if the lines are parallel, so I can apply basic proportional theorem, and from that the ratios I will got equal, and that is what it told us to prove. Okay, it's very simple. Yeah, now students, let's start with the practice 1.2 sum number 10. It is activity based sum over there, and it is very simple. Here they have given x is any point in the interior of a triangle. Now you have a triangle DEF. Look at the triangle DEF, and x is in the interior of that over there. Point x is joined to the vertex of a triangle. That means your XE, XD, XF is been joined. Can you see that over there? Yeah, and then they told that they have given that PQ parallel to DE, PQ parallel to DE, it is given to us. QR parallel to EF, it is given to us. QR parallel to EF, given to us. Look at that properly. Fill in the blanks. You have to fill in the blanks. And then they told to prove that PR parallel to DE, DF, PR parallel to DF. PQ parallel to D is given, QR parallel to EF is given. You have to prove that PR parallel to DF. This is a proof sums. Okay. Now here, how to go through it here? It's very simple. You just have to fill in the blank. You have to first go in triangle XDE. Where is your XDE? For them, for you to understand, what I'll try to do here is I'll try to rub the remaining part of the diagram. I will show you only XDE. Now you check this out today, that I have drawn this XDE. I have shown this only the XDE, remaining part I have rubbed it out of there, so that you can understand over there. So here in triangle XDE, you have over here PQ parallel, this is your XDE, PQ parallel to, now here in this case you have a PQ parallel to DE. And this is what over there PQ. Can you see the diagram? PQ parallel to DE. And what is that over there? PQ parallel to DE is given to us. That is all. So here you have to write it over here, given. PQ parallel to DE, given. Now if it is parallel, do you know that over there? That by basic proportionality theorem, it's very simple. XP upon what will come there? PD. Here it will come what? XP upon PD. You can see this XP upon PD because PQ parallel to D, and you have to start from here. XP parallel to PD is equals to XQ parallel to QE. Can you see that? XQ parallel to QE. So you have over here in this case XQ upon QE. Can you see this over there? That is because of the basic proportionality theorem. XP upon PD is equal to XQ upon QE. XQ upon QE. I finished with this over there. Now they told to go in triangle XEF. So where is that? EF. So you will be having here, I think so this is will be your triangle XEF, and here if you check this, there is your R, you have your R coming up. So I'll be rubbing out for a time being this part, and I'll be having what over here. In this case, you have again the triangle XER, XEF, sorry, XEF. You have QR parallel to EF. Again, QR parallel to EF is given in your question. Like that, how you have given PQ parallel to DE. So QR parallel to EF is given to us. So here you have to write it over here given. I have to write it over here given. So when I write, this is what we got it given coming up. Now next, same thing like what we did on the top over there. We have X in triangle XEF. You have QR parallel to EF. So can I have over here in this case XQ? Again we will be having XQ upon QE. I can have over here XQ upon QE. XQ upon QE is equal to XR upon RF. XR upon RF. This is what we lines are parallel. Therefore the ratios are equal. And that is because of again the same thing. Basic proportionality theorem. So we will be having over here basic proportionality theorem. Okay. Now look at that. We have given this as a statement number 1 and this as a statement number 2. I'll be drawing the diagram back again. If you see this, so then a full diagram, I'll be drawing it again. You have over here in this case, the name of the triangle is DEF. Name of the triangle DEF. And you have over here, one X is there, this is there. Your X coming up here, and then you have these lines are. And the name of this is here PQR. PQR. Now, here you can see this over there from this question. Here will be XP upon PD is equal to XQ upon QE. Statement number 1. XQ upon QE is equal to XR upon RF. Now here if you check this out carefully, that this XQ upon QE and this XQ upon QE is coming same for both the things. Can you see that over there? So this shows that if XP upon PD is equal to XQ upon QE and XQ upon QE is equal to XR upon RF. So that shows that these two are also equal to each other because they are equal to same ratio. So can I have over here XP? Can I write over here XP upon PD is equals to, can I write it over here XR upon RF? XR upon RF. So XP upon PD is equal to XR upon RF, and that is what I got it from statement number 1 and 2. It is written over there. So let's come to the this triangle where we what we had over there. XP upon PD is equal to XR upon RF. So if I come back to this triangle over here, that if you check this out over there, that here in this case what we have proved in this triangle, in triangle we have over here DXF, we have proved that X3, what we have proved that over here in this case is XP upon PD is equal to XR upon RF. So if these ratios are equal, then the lines are parallel. We have done that over there, and that is then we can say that PR is parallel to DF, and that is because of what? Converse of basic proportionality theorem. Here the lines are parallel, the ratios are equal. That is basic proportionality theorem. Now here what we did over there, the ratios are equal, then the lines are parallel. So what you have to write it over here is nothing but converse of basic proportionality theorem, and that is how what they told us to prove. They told to prove that PR parallel to DF, and PR parallel to DF we have already proved that over there, that PR is parallel to DF, and this is why, because of converse of basic proportionality theorem. Students, we have completed with a 1.2 practice at 1.2. Now we are going to go for practice set 1.3. So before we are going to go for practice set 1.3, again I have to explain you a lot of things over there. Now fold your hands and look at to me over there and listen to the explanation. If you understood this, then you'll understand the sum over there. Now what is this over there? It's very simple part. Whatever we have done it into the 9th standard, and now what you are going to do it in the 10th standard. Let's see. Now, do you remember that we have done in 9th standard congruent figures? So I just explained you the first two part about that. The congruent figures and the similar figures. Two things we are going to talk about that. Now, what are congruent figures? Now, if you check this out over there, that we have a congruent figure. Now, for a figure to be a congruent figure having same shape and same size. That is, for a figure to be a congruent, we must have same shape and same size. That is what the thing, very simple part. We have, what is that over there? I'll give one good example about it over there. I'll take my left hand side and I'll take my right hand side and I'll touch it out over there. Can you see that? Exactly, it is fitting to each other. Okay? Yes or no? It's like a namaste. Can you see that other thing? Yeah. Everybody can see that. Is that my hand, that is left hand, and the right hand is exactly fitting one above the other. You are able to see anything bigger or smaller? No. Exactly fitting one above the other. So can I say my left hand is congruent to my right hand? Okay. Palm. Can you see this over there? Same way, take to your algebra textbook. Take your algebra textbook and take your friend's algebra textbook and try to fit one above the other. It will exactly fit one above the other. So can I say that over there? That both the textbook of algebras are congruent to each other. One more example I am taking. Take 1 rupee coin and take another 1 rupee coin and put it one above the other. They will exactly fit each other. So such a figure which is having same size, same shape, that means that figures are called as congruent figures. What they are called as? Congruent figures. Now for example, this next is today. What about the similar figures? Let's see about the similar figures. Figures having same shape and not necessarily the same size. It must have same shape and not necessarily the same size. So that figures are called as, what is that? Is nothing but similar figure. For example, you must have seen over there, you have gone to visit to the Taj Mahal, you see such a big monument and it's a very 7 wonders of the world. You see such a big monument was the thing of Taj Mahal. And then later on the shop also you get it a small Taj Mahal models. Okay. So it is what? What that is same, that's such a big, you get a very small way, you can bring it in the house and you can keep it in your house also. So it is nothing but you will be getting same shape but not of same size. Are you going to get it over there? Same example I took it over there is nothing but I took my left hand palm and then right hand palm and I touch and I told it is congruent. Now do one thing over there. You take your left hand palm and take a palm of a person, of a child which is of 5 years or 6 years old over there and try to touch it to your palm over there. It will exactly fit? No. It will be smaller. So that is what the shape of both the palm is same but size is not same. So that is what we are going to call it as the similar figure having same shape and not necessarily the same size. It can be have a same size but not necessarily the same size. Okay, so this is what congruent figure, same shape and same size. Similar figure, same shape and not the same size. Not necessarily same size. Size is not same. And we have done the congruency. Do you remember in the 9th standard? When the two figures are congruent, then we are mentioned by symbol. Can you see this symbol or two slipping line and there is a curve over there? So can you see that this is the symbol indicating the congruency. And this is the symbol indicating the similarity where there is no two lines are down. There is no two lines down or something there. So can you see this over there? So here this is about I explain you the congruent figure, I explain you the similar figure. Okay, now we have done in your 9th standard, we are going to talk about not about the figures, we are going to talk about the triangles. What are the triangles? We have studied in your 9th standard about the congruent triangle. For a triangle to be a congruent, we have studied about that the corresponding side ka measures must be equal, the corresponding angle ka measures must be equal. Okay, that is what we studied in the 9th standard. All the three sides ka measurements must be equal. Okay, corresponding side must be equal and all the three corresponding angle ka measures must be equal. Then only then the two triangles are congruent to each other. Now what about, let's see, a two triangles similar. If a two triangles are similar, what we are going to see, I am going to show you that today. Suppose I have a two here there is one triangle named as ABC. It is having a measurement 5, 6, 7. And I have another triangle which is the name as PQR. I will be drawing a triangle little down so that you can see this way. I have another triangle PQR. I have this is a bigger triangle. Yeah, are they same over there? No. You have PQR. I have this triangle coming up PQR. Now here I'll be writing the measurement is what 10. I'll be writing the measurement of this side is 12 and this I'll be writing as 40. Okay. So here can I say these two triangles are congruent? No, because can you see the measurement of the corresponding sides are not equal. For a triangle to be similar, for example, if I want a triangle AB, I must have ABC similar to triangle PQR. I want a triangle for a to be a similar. If the two triangles are similar, what are the things coming up? If you check this out, then that is the AB. I can take that AB. And the corresponding side to AB in the triangle PQR is what? PQ. This is the PQ. And I take the measurements 5 upon 10. So I will be getting 5 on the 5, 5 to the 10. I got the ratio. There is nothing but 5. Oh, that is 1 by 2. AB upon PQ ka ratio. Okay, I am taking that ratio. Then the BC. Here check it out BC. Here corresponding side to the BC is what? QR. And that is what we are 6 upon 12. 6 1 is 6, 6 2 the 12, I am getting the ratio 1 by 2. And then I will be taking what over here, in this case AC. AC and corresponding side to AC is nothing but here in this case PR. AC is what over here? AC corresponds to PR. AC ka value is what? 7 upon 40. Can I have PR ka value 14? 7 1 is 7, 7 to the 40. That can you see that? The ratio of all the three sides are coming what? 1 by 2, 1 by 2, 1 by 2. Can you see this? 1 by 2, 1 by 2, 1 by 2. So you can make it out the way for when the triangles are similar, then the ratio of the corresponding sides are in proportion, or ratio of the corresponding sides are equal. You can say that the ratio of the corresponding sides are equal. So what I can say that that is the AB upon PQ will be equal to BC upon QR is equals to AC upon PR. Now if you check this out all the three ratios are equal. So that shows that the ratio of corresponding side in similar triangle, the ratio of the corresponding sides are equal. The measurements are they are not congruent, but the ratios are equal. Ratio of the sides are equal. For that so I can write it over here, the ratio of corresponding sides are equal. Now one more condition coming up over there, that if this about the sides, what about the angles? Now do you know that the shape of a figure depends upon the angle. So naturally the shape are same, size is different. Okay, so if the shape same, then the angle has to be same. Suppose if I tell you that this is what 30 degree, so this will be 30 degree. This is what 60 degree, so can I have this is 60 degree? Can I have this 90 degree? So can I have, for a time example I'm telling this is a 90 degree. So you can make it out that that angle A is congruent to angle P. And angle B, this is corresponding angle. A and P are corresponding angle, and B and Q are corresponding angle, are congruent, and angle C is nothing but congruent to angle R. So if the triangles are similar, the ratio of the corresponding sides are equal and the corresponding angles are congruent. So can I write it over here? Corresponding angles are congruent. So for a two triangle to be a similar, this is the condition. How is it in the two triangle to be a congruent? That the corresponding side must be congruent and the angles must be congruent. But in the similarity, for a two triangle to be similar, the ratio of the corresponding side must be equal and the corresponding angles are congruent. That the measure of the corresponding angles are congruent for a two triangle to be a similar. It's easy. So just keep in your mind for what are the conditions for a triangle to be a similar. Okay.